In this video, we're learning how to solve quadratic inequalities, and if you look at the top of our screen, we have 5 steps that we're going to follow when we're solving quadratic inequalities. So let me show you guys how we can use these 5 steps by working through example 1. So example 1 says x squared minus 9 is less than or equal to 0. So our first step when solving quadratic inequalities is to get every term to one side. And in this problem, we already have both of our terms, our x squared and our minus 9, on one side. So we're going to move on to step 2, which is factor and simplify. So what we want to do is factor the left side of our inequality. So we have 2 terms here. We have an x squared and we have a minus 9. So this is called the difference of 2 squares. So when we're factoring the difference of 2 squares, what we want to do is take the square root of the first term, so the square root of x squared, which is x. We're going to put that in both of our parentheses. So we're going to put that in the first spot in both of our parentheses. And now we want to take the square root of the second term. So the square root of 9 is 3. And we're going to put that in the second spot in both of our parentheses. And then we're going to put a plus between the terms in one set of parentheses and a minus between the terms in the other set of parentheses. And you can switch the order. You can have x minus 3 times x plus 3. The order of that multiplication doesn't matter. And then we know that this is less than or equal to 0. Now we need to find the roots or the zeros of this equation. So to find the roots or the zeros, we're just going to take each factor and set it equal to 0, and we're going to solve. So we're going to set x plus 3 equal to 0, we're going to set x minus 3 equal to 0, and we are going to solve for those roots or those zeros. So on the left, we're going to subtract 3 from both sides, so we get 1 root of negative 3, and on the right, we're going to add 3 to both sides, so we get another root of positive 3. So we get that our roots or our zeros or our x-intercepts, those are all interchangeable, are negative 3 and 3. So now moving on to step 4, we're going to create a number line using the roots. So over here, I'm going to go ahead and draw a number line, and I only need to put these 2 roots on my number line. So I'm going to put negative 3 over here, and I'm going to put 3 here. And this is called a sign chart. So what we want to do now is test every part of this number line. So we're going to pick numbers that fit within every part of this number line. And when I say part, I mean like this part here, this part here, this part here, between our roots. And we're going to see if they work in our inequality. So for this first part on the left, I'm going to put this in pink so we know that that's what we're testing. Let's say that x is negative 4 because that is to the left of negative 3. So that fits on this pink part of our number line. So if I test negative 4 in my original inequality, right? So instead of x squared minus 9, I'm going to say negative 4 squared minus 9. I want to see if this is less than or equal to 0. So negative 4 squared is 16. So 16 minus 9 is less than or equal to 0. 16 minus 9 is 7. So we have 7 is less than or equal to 0, which is not true because 7 is greater than 0. So I'm going to put an x on this part of my number line. You could also put positive because we got a positive 7, but I think putting x's in checks are easier, so I'm going to do it that way. Now let's test this middle part of our number line, which I'll put in blue. So let's test x equals 0 because that fits between negative 3 and positive 3. So instead of x squared minus 9, I'm going to have 0 squared minus 9 is less than or equal to 0. 0 squared is 0. So I have 0 minus 9 is less than or equal to 0. And 0 minus 9 is negative 9. So I get negative 9 is less than or equal to 0, which is true. So I'm going to put a check mark at this part of our number line. And then finally, we need to test something for the right part of our number line. So we'll put that in green. So we need something greater than 3. So let's just test x equals 4. So over here, instead of x squared minus 9, we're going to do 4 squared minus 9. We want to see if this is less than or equal to 0. 4 squared is 16. So we have 16 minus 9 is less than or equal to 0. and 16 minus 9 is a positive 7. So we get 7 is less than or equal to 0, which again is not true because 7 is greater than 0. So we get that this part of our number line does not work. So what we know is that because we got a check mark in this part of our number line, anything within this section is going to be a solution. And then we have to decide if -3 and 3 are also solutions. So because our original problem says that x squared minus 9 can be less than or equal to 0, and we know that -3 and +3 actually make x squared minus 9 equal to 0, we know that those are part of our solutions. So I'm going to put closed circles here just so we know that. So anything between -3 and 3 inclusive are going to be our answers for this problem. So we can write that -3 is less than or equal to x, which is less than or equal to 3, and that's going to be our answer. And we can also write this in interval notation as anything from -3 inclusive up to +3. So I'll also box this as our answer. Let's go through some more examples. So example 2 is x squared minus 13x plus 36 is greater than 0. And for this problem, we already have every term on one side, so we get to skip step 1. So we need to factor and simplify. We can't simplify anything, we're just going to go straight into factoring. So we need to factor x squared minus 13x plus 36. So what we want to do is think of two numbers that multiply to positive 36 that add to negative 13. And if you take a second and think about that, you should get -9 and 4. So we're going to get x minus 9 times x minus 4 as our factors, and this is greater than 0. And now we want to move on to step 3, which is find the roots or the zeros or the x-intercepts. Remember, those three words are pretty much interchangeable. So what we want to do is set each factor equal to 0 and solve for our roots. On the left, we're going to add 9 to both sides. So we get x is equal to 9, so that's one of our roots. And on the right, we're going to add 4 to both sides. So we get that x is equal to 4, so that's another one of our roots. And now we want to create a number line using the roots. So we're going to create this number line or a sign chart. So we're just going to put our two roots on a number line. So I'm going to put 4, and I'm going to put 9. And now we need to test each section of our number line to see if it works in our inequality. So I'm going to test this left section first. So I need something that is less than 4. So let's just test x is equal to 0 because that's an easy number to test. I always like to test 0. So instead of x squared minus 13x plus 36, I want to do 0 squared minus 13 times 0 plus 36. I want to see if this is greater than 0. 0 squared is 0, minus 13 times 0 is 0, plus 36 is greater than 0. And we get 36 on the left and greater than 0. 36 is greater than 0, so this is true. So I'm going to put a check mark at this part of our inequality. And now I want to test this middle section here. So I need some number between 4 and 9. So let's just test x equals 5. So again, I'm going to plug 5 in for x in my original inequality. So we'll have 5 squared minus 13 times 5 plus 36 is greater than 0. 5 squared is 25. 13 times 5 is going to give us 65, so we get minus 65 plus 36 is greater than 0. And if we do 25 minus 65 plus 36 in our calculator, we will get -4. So if -4 is greater than 0, -4 is not greater than 0, so this does not work. So I'm going to put an x in this part of our number line. And finally, I want to test this right part of our number line over here. So I need a number greater than 9, so I'll just do 10. So we're going to test x equals 10. So I'm going to plug 10 in for x in my original inequality. So I have 10 squared minus 13 times 10 plus 36 is greater than 0. 10 squared is 100 minus 13 times 10 is 130 plus 36 is greater than 0. And if we do 100 minus 130 plus 36 in our calculator, we should get 6 is greater than 0. And 6 is greater than 0, so that's true. So I'm going to put a check. So I'm going to put a check here. So we know that this pink part of our number line contains solutions, so anything below 4. And then we know that our green part of our number line also will contain solutions, so anything above 9. And now we want to figure out if 4 and 9 are also solutions. So in this inequality, we know that x squared minus 13x plus 36 has to be greater than 0. It cannot equal 0 this time. And we know that x equals 9 and x equals 4. So if we plug in those x values, that's going to turn our inequality into 0. So if we plug in 9 for x or 4 for x, we're going to get a 0 out, which is not part of our solution because we need it to be greater than 0. So I'm going to put open circles at 4 and 9 just so we know that those are not part of our solutions. So we get our solutions as x can be anything less than 0 but not including, or x can be anything greater than 9. And if we want to write this in interval notation, we can say x can go from negative infinity up to 4 but not including 4. And then we're going to put this u for union, so it can also be anything from 9 but not including 9 up to positive infinity. So this is how we can write our solution in these two ways. Let's go through some more examples. So for this example, we have 5x squared minus 12 is less than 4x squared plus 4x. So for this example, we have terms on both sides of our inequality. So we have to start with step 1, which is get every term to one side. So I'm going to move the terms on the right side of our inequality to the left side. So I'll start by subtracting 4x squared from both sides of our inequality. On the left side, 5x squared minus 4x squared is going to leave me with an x squared. So I have x squared minus 12. On the right side, we are just left with 4x. And now I want to move this 4x from the right to the left, so I can do that by subtracting 4x from both sides of our inequality. On the left side, I get x squared minus 4x minus 12. And on the right side, I'm left with 0. So now we're going to move on to step 2, which is factor and simplify. So I'm going to factor x squared minus 4x minus 12. So I need two numbers that multiply to negative 12 that add to negative 4. So if we take a second and think about that, we should get negative 6 and positive 2. So we can factor this into x minus 6 times x plus 2 is less than 0. And now we're just going to find our roots. So we're going to set each factor equal to 0 and solve. So we have x minus 6 equals 0 and x plus 2 equals 0. And for the left equation, we're going to add 6 to both sides. So we're going to get x is equal to 6 as one of our roots. And for the left or the right equation, we're going to subtract 2 from both sides, and we're going to get x is equal to negative 2 as our other root. And now we're going to go to step 4, which is create a number line using our roots. So I'm going to put negative 2 and positive 6 on our number line. And now we have to test each section. So first we have to test this left section over here. So we need some number that is less than negative 2. So let's just use x equals negative 3. And I'm going to show you guys a shortcut for testing each interval on the number lines. So typically we're using the non-factored form of our polynomial to test, but it's actually going to be easier if we use the factored form. So we're going to use this factored form right here. And I will show you guys how to do that. So let's start by writing our factor form. X minus 6 times x plus 2 is less than 0. And now we're just going to do the same thing that we've been doing. We're going to replace x with our x value that we chose of negative 3. So we have negative 3 minus 6 times negative 3 plus 2 is less than 0. And we're going to simplify each set of parentheses. So negative 3 minus 6 is negative 9. And negative 3 plus 2 is negative 1. This is less than 0. And negative 9 times negative 1 is a positive 9. So we get 9 is less than 0, which is not true. So this part of our number line does not work. So now we're going to test the middle section. We need some number between negative 2 and 6. So I'm going to pick x equals 0 because it is an easy number to work with. I'll start by writing our factored form. So remember that is the form we are using to test. And we're going to replace x with 0. So we're going to have 0 minus 6 times 0 plus 2 is less than 0. 0 minus 6 is negative 6. 0 plus 2 is 2, is less than 0. And negative 6 times 2 is negative 12. So we get negative 12 is less than 0, which is a true statement. So I'm going to put a check in this middle part of our number line. And finally, we want to test the right section. So we need to pick a number bigger than 6. So let's just say x is 7. So let's write our factored form. And we are going to replace x with 7 this time. So we're going to have 7 minus 6 times 7 plus 2 is less than 0. 7 minus 6 is 1. 7 plus 2 is 9. And 1 times 9 is 9. So we get 9 is less than 0, which is not true. So we're going to put an x in this part of our number line. So we know that this middle part of our number line is where our solutions lie. And now we have to figure out if negative 2 and 6 are part of our solutions. If we plug in negative 2 and 6 into our polynomial or into this factored form, we know that we're going to get a 0 out. But we know that our polynomial has to be less than 0. It cannot equal 0 this time. So we're going to put open circles at negative 2 and 6. So we get a solution of x can be anything between negative 2 and 6 non-inclusive, so not including negative 2 and 6. So we can write it like negative 2 is less than x, which is less than 6. And if we want to write this in interval notation, we can use soft brackets going from negative 2 up to 6. So either way, you can write your answer. So hopefully this video helped you guys understand how to solve quadratic inequalities. If you guys want some more practice with similar problems, check out the link in our description for a free practice worksheet.